Welcome to Science by PK. This is the place where we unravel the mysteries of the universe, simplify complex science, and dive into topics that are as fascinating as they are mind-boggling. If you love exploring the unknown and learning something new every day, you're in the right place. Don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss another adventure. And today we're talking about antimatter, one of the rarest, most powerful, and most expensive substances in the universe. It's a topic that feels straight out of a science fiction, but it's real as the device you're watching on is. Let's dive into what antimatter is, where it comes from, and why it's so important. Antimatter, often called the mirror image of matter. Every particle of antimatter, like protons and electrons, has an antimatter counterpart. For example, a proton has an antipron, and the electron has a positron, which is identical in a mass but has the opposite charge. When matter and antimatter collide, they annihilate each other in an explosive release of pure energy. This reaction is so powerful that just 1 gram of antimatter could produce enough energy equivalent to 34 kilotons of TNT. To give you an idea, that's almost 3 times more powerful than the bomb that was dropped on Japan. Imagine the energy potential locked in within something smaller than a sugar cube. The story of antimatter begins in 1928 when a physicist, Paul Dirac, predicted its existence through his groundbreaking equations. At the time, the idea seemed purely theoretical, but in 1932, Carl Anderson discovered that the positron while studying cosmic rays, proving that antimatter is real. This discovery marked the beginning of a scientific journey that continues today. Antimatter is extremely rare in nature. It forms during high-energy cosmic events like supernova explosions and cosmic ray collisions. Even here on Earth, antimatter is created in trace amounts when cosmic rays hit our atmosphere. But these particles are fleeting away. They annihilate as soon as they meet matter, which makes them incredibly hard to detect and to study. To date, scientists have created antimatter artificially in labs using particle accelerators like the Large Hadron Collider, the LHC, and CERN in Switzerland by smashing particles together at nearly the speed of light. Tiny amounts of antimatter, such as positrons and antiprotons, are produced. However, the process is incredibly inefficient. CERN has produced only about 10 nanograms of antimatter in total, less than the weight of a single grain of salt. The big question is, how much antimatter exists in the universe? The answer is not much. If you gather all the antimatter naturally occurring on Earth, it wouldn't even be enough to light a single bulb for 1 second. Scientists believe the universe started with equal amounts of matter and antimatter, but for some reason, matter won out. That's why this happened, and this is one of the greatest mysteries in physics. But now let's talk about the cost. Producing antimatter is the most expensive process known to science. To create just 1 gram of antimatter, it would cost, as we estimate, about 62.5 trillion. That's more than the combined GDP of many countries. To help you visualize this, 1 gram of antimatter is worth as much as 1,400 metric tons of gold. That's 50,000 times its weight in diamonds. The cost of antimatter could buy 5 luxurious Burj Khalifas, the tallest building in the world, or millions of luxury cars. If antimatter were a real estate investment, it could buy a small city or even a fleet of private jets. Comparison makes clear on how valuable and inobtainable it is. So what makes antimatter so expensive? First, it's incredibly difficult to produce. Second, it's almost impossible to store. Since antimatter annihilates on contact with matter, it must be stored in magnetic traps of high vacuum chambers to prevent it from touching anything. Even a tiny leak would result in a massive explosion. Despite these challenges, antimatter has practical applications that are already changing the world. In medicine, antimatter plays a key role in positron emission tomography, PET. Scans, a powerful diagnostic tool used to detect diseases like cancer. PET scans use protestic to create detailed images of the body, enabling early diagnosis and more effective treatments in physics research. Antimatter is used to study formidable particles and forces. It helps us and scientists explore why the universe is made mostly of matter and what role antimatter played in the early moments after the Big Bang. To sum it all up, antimatter is one of the most fascinating substances in existence. It is the most energy-dense material known, capable of powering cities or spacecrafts. It's also the most expensive substance ever created, far surpassing gold and diamonds or any other material we know. Its rarity, immense power, and mysterious origins make it one of the greatest scientific puzzles at our time. If you found this deep dive into antimatter fascinating, give this video a thumbs up and share with friends. Don't forget to subscribe to the channel Science by PK for more videos on the wonders of the universe. Be sure to check out my other videos on topics like black holes and the Big Bang. The links will be in the description, and we'll see you in the next one.